Hi, everyone, and welcome to Enhancing Space Missions, Advanced Connector Solutions for Communication and Navigation, part of the 2024 Space Communications and Navigation Summit, with thanks to our sponsor, Omnetics Connector Corporation. I'm your moderator, Amanda Hosey, and joining me for this 15-minute session is Travis Newman, who serves as the Special Project Manager for Omnetics. Questions for Travis may be sent by the chat box on your right, and we'll be addressing as many as possible at the end of the program. Now let's move on to the presentation. Welcome, Travis.
All right, well, thank you, Amanda. Thanks everybody for joining. As she had said, I'm Travis Newman, Special Projects Manager from Omnetics Connector. We're going to talk about really connector use in space and really some things to keep in mind. A little bit about Omnetics. As of this year, Omnetics is celebrating 40 years in the high-rel cable and connector space. And really what that means is for high reliability is it comes down to the markets. We serve from heaven to hell: space, aerospace, military, medical, oil and gas. And we make a wide range of connectors. So if for getting your information out from the board to the edge of the box, we've got board mounts, or even box to box in terms of harnesses. We regularly integrate other vendors' connectors to give you the custom solution that really gets your application off the ground. Our focus here is primarily micro and nano mini connectors per the mil spec. One of the things that regularly pops up when it comes to space is nobody necessarily wants to eat at the new restaurant until they see the reviews, is heritage. So what's your heritage is the question. And just looking at projects that we've done here at Omnetics, and this goes back to about 2010. I put a few of them up here from the Mars rover in terms of some previous ones, some flyby projects, and then even looking forward, some of the other ones that we have content on. So we've got a wide range, and these are just NASA projects. We've got a wide range of other projects we've done and regularly do with customers. Some of the applications that we fulfill is really around attitude control, so navigation, power delivery, and thrust. And then you got, at some point, you're, for lack of a better term, sending up a wireless router. You need to get that data back to the ground. So primarily where you'll see Omnetics connectors, and I didn't list this, but like IMU type stuff for attitude understanding, star finding, reaction wheels, control moment gyros, that sort of thing. Or even a lot of times you'll have solar panels that'll bring power into the system to juice up batteries or capacitors. And really that just depends on what is it in the dark? Are you or revolving around the earth with light and dark, that sort of thing. And the big one, right? Getting the data back to the ground. So one of the issues that has come up is using industry standard USB, HDMI type connectors. They don't really stay mated that well, especially with the shock and vibe that you experience through launch and that sort of thing. So one of the things that we've done is developed different or solve this different protocols using compliant pins and sockets. And that way, when you need to transmit data from S-band up into the X-band, you can get that done with these types of connector solution and others. When you look at moving into the higher data rates, let's say maybe not necessarily KU, but K, which I don't have on here, KA, or even E, for I know Starlink uses that, you're going to end up with some different solutions. Generally, that's an RF type application or fiber. So we're just going to stick to pins and sockets. Really, what that comes down to is getting that off the ground and into space is having the right mix of technology in terms of materials, manufacturing, and manpower. So use materials that withstand the space environment, and also built in such a way that you're not going to experience reliability issues further down the road. Part of that is having a workforce with the right skill set. And in the last couple of years, we've invested in that skill set. And that's where I have a note about over 10% of our manufacturing is currently certified to IPC 620 space addendum, which for us is 30 to 40 people in manufacturing. So when you get to the point where you need to pick a connector for space, you have a myriad of options on the table, right? There's just tons of them, and that's one of the things that I've heard being in some of the meetings with like SOSA and that sort of thing. So how do we pick the right connector? And there's a few ways of looking at it, and maybe you want to think about it in terms of taking a trip and how do we get there. So you've got a lot of shock and vibe during launch. And there's even acoustic testing that I just learned about this year. Very interesting stuff. You have temperatures to deal with. And then really once you get there, the longevity of things. So the first slide I have, this is more of a pro tip or just a tip. As engineers, a lot of times when we see, let's say like for a micro connector, which is the bottom center-ish one there, we'll say, okay, that guy's good for 3 amps. We're going to derate it to 1.5 amps. So if I have some sort of application, maybe I'm running a camera or something of that nature. So I have a 1.5 amp draw, which is high, but we're using this as an example. And I need to move some data back and forth. I can get that done with a micro connector. Well, we're always tasked for smaller size, weight, and power swap. So we want to get the same performance in a smaller footprint. And this is more about when you're choosing a connector, keep in mind that you can share pins to do things like power delivery and that sort of thing. And interestingly enough, these are both 9-position connectors. One's a micro D and one's a nano D. You could potentially fit 2 37-position nano Ds in that same area. So something to keep in mind. And then as I mentioned, compliant pins and sockets. So there's a fair amount of testing that goes on to be able to be certified to 83513, which is for the micros, or 32139. All that testing involves, there's a number of them, but the main thing for this point is shock and vibe. There's profiles for the rockets. You can compare that to the performance of the connectors you're using. And the reality is a lot of times you'll have greater performance here than what you're going to need for launch. And just a note, interesting note, vibration test is hours long. So if it takes you hours to get to space, you might have bigger problems than the connectors. And there's a number of different contexts in industry too that meet these requirements. They're all same electrical requirements and same pull test, that sort of thing. One of the big things too, as I mentioned in manufacturing, is about doing it in such a way that you're not going to cause issues, which is why we laser strip to prevent nicked wires, which could have current or data transmission issues, that sort of thing. So points to keep in mind. Additionally, temperature, once you get up there, that can be a big thing. And generally speaking, connectors are minus 50 to 125 C. We see it asks for ranges outside of that. And I've got a few notes on just the range. But the big thing to keep in mind here is picking a material set with the coefficient of thermal expansion that aligns with your assembly. And that way you can prevent things like it falling apart. You could prevent leaks, that sort of thing. Generally speaking, when you're outside of kind of that negative 50 to 125 range, you end up with high temp epoxies. Or in the more extreme cases, that's really when you should start looking at hermetics, because they can match the glass to the materials as well for that range. And just one other thing to keep in mind when choosing a connector for getting your data back to the ground is outgassing. And that can have issues with optics and that sort of thing, really depending on what you've got in your box. And then kind of last slide, just for notes, radiation and shielding. So that you've got a couple different types of really nasty radiation in space where you may have gamma or solar bursts, that sort of thing. So we regularly see requests for different shells when you talk about like hardening components, so to speak. Most of what we do is aluminum with a nickel plating, but in the events that individuals need more shielding, we've very much done gold plating on shells, stainless. We've even had requests for call it higher density metals as well, specifically around shielding from like gamma rays and that sort of thing. And there's some plated plastic connectors. We don't necessarily make those, but I know it's a thing in industry. So I'm just going to glance over that. The other thing is protecting the wires. I've got a picture down on the bottom left that has braid, some spiral wrap, and some foil on it. This is a USB type cable. And one thing to note is depending on the level of attenuation you need, spiral braid will get you 30, a nice interwoven overbraid with good coverage can get you to 60. And when you need real serious shielding, that's when you have to start looking at foil wraps and that sort of thing. But again, it's always a trade in terms of flexibility. And then just some things we're looking at. So we do a lot of 3D printing here. We have a Projet 2500 that works great, but we're looking at smaller and smaller because that's really where things are headed. So we've been doing some work with BMF, Boston Microfab, for the metal side, 3D microprint Germany. And then we've been moving into magnet wire and that sort of thing as well. We actually procured lasers for stripping that and primarily focused around niobium, titanium, and phosphor bronze. So I've just really kind of dropped a thimble full of information in what could be an ocean here in terms of some of the connectors for space and things to keep in mind. So with that said, if there's any questions, wide open to that. And for those individuals that may not necessarily want to put something up, contact information as well.
All right. Yeah. Thank you so much, Travis, for all that information that you shared with us. And note to the audience, you can still send questions for Travis through the chat box, or you can email him at the email address on screen. But we do have a couple of questions here for you, Travis.
Sure.
What information do you need to determine if micro or nano is suitable for an application?
The easiest thing for making that choice, and this is my opinion, is a understanding of what pinout you need and the current requirements that are going to be needed as well. There may be instances where you're doing signaling and nanos might not have enough current. I hope that's not the case, but it does happen. So that would be the first thing, just a nice pinout and understanding what signals you need.
All right, great. Let's see. Is there anything we can do to help with reducing outgassing and improving long-term performance before flight?
Well, there's one kind of there's one regular thing that you can do, and this does happen even when you have materials that are they do fairly well for outgassing. One of the common things is to do a vacuum bake, because in space you don't have that atmosphere. So you'll put it into an oven and vacuum it and then bake it at 150 C is a pretty popular temperature. It really depends on the part, but you'll bake it for 24 hours. And then what that'll do is that'll allow those volatile compounds, whatever may be there, to outgas. And then when you go to put it into your particular box application solution, whatever you want to call it, then that process has really been taken care of already. So that's just one way of doing it.
All right. Well, thank you very much, Travis. Unfortunately, that is all the time we have for this session. My thanks again to Travis Newman, as well as all of you in the audience who joined us. We'll provide Travis with any questions that came in for follow-up later. Our next session, Innovations in the Space Communications and Navigation Sector, will begin momentarily on stage 2. Please join us there.